No.
Hi. Oh, wow. I didn't know that trick.
Yeah.
You kicked out the bot?
Yeah. At
Where
least from that company.
where did you learn that?
I think I just Googled how,
Okay,
like, this bot name and how to make it leave.
cool.
Yeah, but there is, I think, the other type of bots sometimes attending this meeting that I don't know how to do that,
Kick.
or I don't remember. I don't remember the command.
Let's see.
Okay, let's wait a minute or two, maybe.
Hey, Mark. Hi, Evan.
Yeah. Hey.
Hello.
Hello?
Hey, Marcus.
Hey, Mark. Cool.
Okay, I think we can start. Copy the agenda. Yeah. Hello and welcome to HCD robustness test meetings. Today is February 25th, and here is the place where you learn and find linearization issues for HCD. As always, we start with questions and answers from community. Are there any topics that anyone would want to add or discuss? Okay. I think we can skip that. There, we can move. There are some things that I think we will discuss, but we can. But part of the triage, there are some things that are happening. So, if there are no questions and everyone is clear why we are here and what we are doing, let's move on to review the ongoing labeled issues, or it's the issues. And there is a, I mean, there are no new issues, but there is one that got an update that I can discuss. So if you're keeping up with what is going on, we have, for a long time, we had a linearization report. Oh, that's a pretty old issue. Yeah, I remember debugging during KubeCon. Yes. So we it was reported a long time, but it was not confirmed. And we were trying for some time debug it using deterministic simulation debugger or multiverse debugger, but it all those attempts failed because the type of simulation that Antitesis does is not a like godlike powers of introspection and memory, like full memory view, but it's more like rerunning the same cases where you can, you can deterministically run the same code, but you cannot get exact snapshots. So that the problem that we couldn't solve is the fact that linearization is a global property, not a local property. So while you could debug a local property easily in deterministic environment, like you can just get to this point and add a assertion or like add a profile or debugger and see what is happening. A global property like linearization is a little bit hard because there are multiple independent code paths on multiple processes that interact with each other, and together under certain conditions they cause linearization to be broken. So that's why linearization is validated not during the tests, like an assertion that we have, like compared to property that we have, a property-based assertion that we have, but it's validated at the end after we have a global view of everything that happened in the cluster. Yeah, so that makes debugging horrendous. And to address that, we on the last meeting we finally made a decision that we will just like keep it stupid simple by the keys rule, and I added the debugging logs. So basically, instead of trying to debug the known a failure and trying rerun it using the deterministic environment, we are just modifying the binary of etcd, adding the logs, or we have some guess hypothesis where it happened. We modified the binary to add additional information to confirm this hypothesis, and we ran the test again. So here, I think I don't know how many rounds, but based on like Marco's previous report, this specific case happens once every second day. So we need 24 hours of execution to get an exploration to get to this bug. So it's pretty rare. Maybe we should have like maybe we should have some estimation. I don't know if Marcus, how easy it is to estimate in production. How do you map to production data? Because that's usually how we measure at Google things when we say, oh, this is reliable because we didn't find any bugs after, I don't know, million hours in production.
Yeah.
In simulation, it's a little bit harder because this is like combination of multiple failures. Like I counted like how many in this around the same idea, how many failure injections we had, or like this is like the only types of failure injections, like
Yeah.
pausing, throttling, like partitioning and things.
Yeah. So just to comment on that a little bit, like it's like previously, like maybe like a month ago, we were seeing this linearization failure like much rarer, like maybe like once
Mhm.
every 2 or 3 weeks. And the reason for that was because there was this one fault setting that was, I guess, that happened at a lower cadence during the tests.
Mhm.
And so like what we realized was that like the linearization bug is pretty correlated to like something getting paused or like some container like not being able to speak with the other two containers. So
Mhm.
we just basically like turned up the rate at which we do those two things. So like we did pausing on a container much more often, or we did like making etcd0
Mhm.
not be able to talk to etcd1 and 2 much more often. And
Mhm.
what happened is that since those events were happening much more frequently, we were able to reproduce the issue much more often. And like Mark said, that was maybe now it's probably we see it like once in 24 hours of testing. So it's like we could probably increase the amount of times we see it even more by like doing like much more pauses and much more like node partitions. But there's only like we can only do them more often until we're like doing them all the time, which doesn't really make sense.
Mhm.
So yeah, I'm sure there's like a little bit more room to like increase to do them like even more, but I doubt like we're gonna like be able to bring the frequency at which we reproduce the issue like down to like
Mhm.
an hour. I feel like the only thing we could probably like, move it down to like maybe every 12 or 18 hours because I think we're doing them pretty frequently right now, which is how we brought it down to 24 hours. But yeah, just wanted to bring that up.
Yeah, on that topic, I would be interested in maybe related thing, which is we to make an impact or like decision about like severity of the issue and like and give proper messaging to, I know, users. We need to have some concrete data how often it can happen, and maybe for that would be useful to know. You said there are two things that impact this. Is there like one is enough, or there always need to be two and they always need to like intersect with each other, like figuring out like, yeah, like narrowing it's more correlation based, not necessarily frequency, but correlation with what things correlate and what things don't correlate. Like you have correlation and correlation calculations for code paths. So that's for debugging, but for users is correlations with failures. So how that would be useful to say, oh, because currently I wrote like, because we don't do any process pausing, but would be nice to have to say, oh, you need both process being paused or like,
Yeah.
and also network disruption. So that confirming that might be useful. Whether
Yeah. 'Cause I don't know if I've cases where there were no pauses and it still happened. But okay, I think yeah, today I'll write some queries to like just get a ton of examples of the
Mhm,
linearization bug just to see what happened in the history leading up to it. And try to like figure out like, oh yeah, okay, this always happens or this sometimes happens or both of
mhm.
these always show up. Um, just to see like maybe if it's just like one fault or like has to be a combination of both. Um, so yeah.
Yeah, that would be useful. Like we would want to, yeah, we like, I think that I at this point I started involving other like tech leads, because like I it's, I mean, more brains, it should be easier to figure out what is missing. So and take them suggestion, like feedback is always, so they're like still, because they're outside of, don't attend this meeting, and they're outside of the thinking that we have, and they're outside of simulation, they're more production focused, or I think they, it's, things are still a little bit unclear, so that would make sure that uh, like having investigating that would make sure to and translate to impact. Like usually we try to say, oh, like this is rare, this is very rare. I mean, you could say it's, I don't know, in production environment, if you don't, I don't know, if you, I don't even know, like if you don't have like abuse of VMs, or like, I don't know, network is sensible network, this should happen like every once a year, or like once 10 years or 100 years. I mean, because then you can multiply it by number per cluster, you can multiply, some companies have pretty big fleets of etcds, so you can multiply it by how many clusters you have, and you get the number how often it happens, and you don't know it. Yeah. Yeah. So it would be good. I don't know, like if you have any, it would be pretty good in the documentation on the antithesis side. How like, what is your guess or score? How often this event can happen? Like if you can inject those failures is good, but yeah, for production SRE, like this third decision, and whether we should do, I don't know, historically we did like even announcements if we did make the huge mistake, and something that was pretty probable. I mean, I don't think it is here, but we should have like easy for triaging the issue. We should have it, and to I don't know, to calm people down, we should have some number. Like I don't know if you can get or ask how people do that.
Yeah, I'll ask to see. I think that would be cool information to have on the website about each fault. But yeah, I don't know who would know about that, so I'll ask around.
Mhm. Yeah. Um, okay. So maybe let me give you a quick overview of what investigation happen. So not going too deep for now. Here is the CL that I added the new zoom it in. Added some new logs. It's pretty simple logs when the request starts, when the request ends, and for reads we do all the writes in etcd go through Raft, which means they are globally linearized and replicated, and assigned commit index for a commit. So they're linearized, which means they're order. There is one consistent order on all machines and IDs match. So that's for writes, so directly. But for reads, there is an optimization that doesn't go through Raft. Doesn't go through Raft replication, and goes through other part of Raft, which is read index, which is an optimization that was proposed in the original paper, where instead of trying to replicate some data, you try to aggregate what is the latest index of write. And you do that usually by asking the leader. And leader cannot just answer you, because it also Raft doesn't guarantee that there is one leader in the cluster or someone claiming to be a leader in a cluster. So if you're a leader, it doesn't mean if you could be a still self-complaint. Leader might not have noticed that it's no longer a real reader. It might have self-nominated or claim it, and followers already left. Like they shut down or they lost the network and cannot communicate, and they decided they picked another leader, because I know there was a partition. So the leader still should do some checking that it's still a leader. And in the end, it returns to the member that handles the index it should use to serve the read. This is called read index, and this member just basically, after getting the index, it just wait until it observes in the replication paths the index that we are seeing. So here is the here are the logs from it. Let me maybe rescale it. And there are two requests that we are interested in here. Here is if we look at takes m, here is the writes. Here the write. Here is the start of the write. Here is the end of the write. And this write was committed as proposed index 11 under revision, separate numbering, but yeah. Raft index mean like if you think about revisions, Kubernetes and things, this is like indexing. They're parallel, independent, but correlated numbering systems. And the difference is index always increases when someone proposes a change. A revision only changes when something is accepted, committed, and updates database. You could also, like, if something doesn't update, so for example, a delete on non-existing key, it will not increase revision. So revision might not always never increases, or there are cases where index will increase and revision will not. Yeah, so there is a commit on revision 4 with index 11 for the committed index. And then after this, a new request starts, a read index. And if you look at this read index, a read request, it ends up with read revision 10. Here is the read index. So basically, we have a request that started after index 11 was committed, but returned that it should read the index 10. In the between logs, there is separate loop that makes requests for this or read requests for performance reasons are batched into. We don't or for single read read request, we don't send for every one of them a separate request for read and ID. We do batch them, so there is a separate read index ID, which is the for request that reads the index. So the request I mentioned before has also like resulted in multiple requests about the read index. So here is, if you look at the read, it's part of linearizable read loop, and in that loop we try to get the read index until we fail, and it has a common ID. So the first read, the current index failed or was sent, but it was failed. It's timed out after half a second. Then there was some Raft disruption or whatever, like Raft logging. I included it because I don't know, someone might be interested in that there was issues with Raft. And then it's also like network throttling and whatever fail points. And then there is, on second request, we get a response with index 10. Yeah, so both also read index request that was used was after we got this index. This index was technically committed everywhere. Yeah, so this is a clear case of linearization, or like even serialization, or it's not serial, but linearization issue, that reads should observe writes that happened before the read. So here the read didn't, like, this reads read snapshot from index 10, even though the latest index was 11. And it's somewhat replaced here, explained here. Sorry. Okay, I clicked something. Yeah, and here is the visualization of this case. So we don't have access to read index, but fortunately the revision also changes. So here we have revision 3 that was the first request was on revision 3. Then we have transaction that here is a transaction with if, like if conditional transaction, because Kubernetes does a conditional transaction that succeeded, which means it was committed and also increased the revision. So we have revision 4. So this means that after get request with revision 3, and the next request should be this. And then we have following read requests that got revision 4. So those are also good. But there is no way how we can connect a request that happened much later with revision 3. Because this transaction ends before this request starts. So in other words, when you are trying to linearize, you are trying to connect those blocks with a line in a way that it makes sense from, like, like single point of view of one client or one server, one process. And you can reorder, you can pick the line, like this connecting line, in any order, reorder them as long as they are concurrent. So we can, like, even though there are, like, this request has started much earlier and ended much later, we can reorder it, because I don't know, it at any point of time those requests could be reordered on the server side, or I don't know, on network, or I don't know, and anything can happen. So we can reorder those, but those two requests we cannot reorder. We cannot say this request happened because before that, because those happened one after the other. There was like 300 or whatever milliseconds between them. 460 milliseconds looks like.
Quick question mark on that. So it looks like the bad request had revision 3, but it's coming from the same client that its last request was also revision 3. I think that was that first one you pointed at.
Yeah.
Is there like any mechanism that like would let the client like reuse the same read index or something like that? Or like
No, and even if it existed, that's a linearization on the client or on the other side. This is still a linearization issue. It's just the bug would be in different place.
Okay, so at the start of like each request, like the client has to ask like, okay, everybody, what is the latest commit index?
I mean, this is a server that handles the request should ask and establish what is the latest state of the
Right,
cluster.
right. The server that the client connects to should be the
Yes.
one asking.
Yes.
Okay. And so then that means
Client is totally unaware of the read index. That's why we needed logs, debug logs for that.
right. So then the server that asked for the latest like read index received something that was basically bad.
Yes.
Okay.
So
Cool.
maybe it asked a leader that was paused, and there could be a pause between it preparing the read index, losing or it read the index, it was 10, then it was paused, and after the pausing, it was no longer a leader, and it returned a response.
Yeah. Yeah.
Yeah, and I don't know how to like now. When I explain it, I don't know how to handle it, because like it means like you. I mean, okay, I know how to. I can guess how to handle it.
What do you guys to handle it?
Yes, but assuming that this is a fix, I mean, I don't think it's easy to implement. We have a similar issue with leases. Is that what happens when a leader, uh, or like I said, there is no in Raft no guarantee that there is one leader. The only thing is that there can be a state of there is or how to say, Raft doesn't guarantee a single leader. It guarantees that if there is a leader, only or no, Raft guarantees that a write can only happen if it's replicated to a quorum of members, but doesn't say anything about the leader. Leader is just an optimization how to write to a quorum of members, and that's way if there is a lead and it goes through a leader, and if the leader is a leader, it will be able to save that write. But if the leader still like works as a leader, but it disconnected, it will attempt to make a write, but the write will fail. So like, but the problem is when there are processes that needs to happen, and their optimization that someone decided, oh, let this process of, I don't know, someone making decisions happen only on leader, or happen on lead. And then we have a problem with those processes. There is a separate issue that those processes can be done incorrectly, and we have bugs for that, for like related to leases, because there could be two leaders in the cluster, and the other leader, the old leader, could be unaware of the new state. So we have bugs related to leases. So here, exact example is etcd has leases, which are a way to give a time to live to a key. You can restrict the life of a key to be, like, say, 10 seconds. And you have mechanism. It's mostly used to provide a distributed lock, so someone can own this key, and but only say, oh, maintain this key. I'm the leader as long as I'm alive and refreshing the key. So there is a way to say this key can only be live for 10 seconds, but you can refresh it. So the problem with leases is the state of the keys. In fact, if they're dead, they should be deleted or not, is only starts on leader. But if there could be two leaders and one got disconnected, we have bug with the new leader starting deleting keys that technically were refreshed by the new leader. So we have a bug with that. We try to mitigate it, and we have idea how to fix it properly, but this is hard. I think here we can try to think about similar fix. Yeah.
Okay.
Yeah. Any questions to that?
So your initial hypothesis is pretty much like the bug can happen because etcd might not implement something around the case where there is two leaders that Raft says is okay.
I mean, here the two leaders is just an example. Is Raft tries to mitigate the problem of two leaders or an old leader by, because the problem, like two leaders happen because it takes a leader up to 1 second to decide that, oh, like I'm no longer a leader and step down. But this mechanism can be disrupted, and overall it takes a second. So you can have a new leader election that happened without this leader, and the leader still didn't double check, and that is no longer a leader. Or it lost, it's no longer selected. So this is like related to the fact that if you disrupt this process or pause the node, it will still respond as if it was a leader, even though for a second it's no longer a leader.
Right.
So if we have read index request, if you pause the member after it prepares a leader, when it prepared, we could check if that member was still a leader. If you pause a leader that was already decided the read index, but it hasn't sent it, and then if it's unpaused after that, and it just sends the request, it will give you return. It will send the response even though it's incorrect. I mean, it's correct based on his understanding because he thinks still a leader, but it takes some time for him to notice that it got disconnected.
So, okay. So in the previous case where like one of the servers like successfully claimed that the transaction was commit index 11, um, would you suspect that there was a pause on that server that claimed there was a commit index 11, but didn't have like a chance to publish the commit index
It's
to the other servers?
it gets a little bit tricky. So fact that index 11 was committed can happen very early because index is committed technically without even announcing it to everyone, but
Oh,
after if it's replicated to quorum, because Raft puts a limitation of the leader election that a member with the longest a leader can be only a member with the longest Raft log. So if so this eliminates the case that you cannot create a quorum without a quorum read. You cannot select a leader that will get quorum of votes to become a leader without observing a right that was accepted by a quorum. Sorry if this is like confusing, but yeah, that's why Raft is confusing. So basically, a leader can as long as leader has a right and replicates it and set to quorum of members, so two other members, it can die, but this right will be persisted because if at any point you would try to recreate this cluster with the same members, there is no way that you would establish you could select a leader that doesn't know about this rights, because a member will only vote for a leader if this leader has a Raft lock greater than his. So you don't vote on someone that doesn't know, like election doesn't agree with you and also knows more. Like if the person has less knowledge than you will not, you would say he's the bad leader.
yeah.
So in that way, a leader after replicate, like second stage of the raft is not needed. So the second stage of the raft would be announcing that that this the commit index has moved. This is not needed to persist a thing. It's just needed to serve reads, because you need to know Um, I mean, it's needed and it's not. Like it's at that point the right is guaranteed. It's just will delay when this right is applied by the members. So yeah,
Hmm.
there and if you include this into like knowledge, there's a lot of edge cases that I think could happen when like, oh, we have one member, this member or a leader, this leader replicates something, but not all members are aware of it, and I don't know. Like I don't even know. Like I would not guess or if I without having a full logs, dumping it of all transactions that happened, who committed when something, and then having this log and giving it to AI to draw me a graph of dependencies, I would not care about like even figuring out what kind of uh, thing happened, what kind of edge case can happen. I would just assume, oh, if we have, if or what I think is the fix, or I don't know if this is a real fix, or maybe I didn't, maybe this check exists, but I don't know. I think I would we should, when a member gets a read index from the leader, it should double check that this member is still a leader. And that's my thought. Maybe we are missing this check. But I don't know. Yeah. Any questions?
Yeah. I was just curious what you think some next steps are for this issue. Do you think like it's worth trying to add more print statements to get more knowledge around it, or do you think that y- the issue's been kind of conceptually thought out for the
Uh,
most part?
I mean, this is hypothesis. We need to like a fix. I mean, how long, if the problem it can be reproduced every 24 hours, how many runs on average, how many runs, what you would need to have probability big enough that you would be sure that this is like fixed.
Oh yeah, I could get that for you.
I mean, I'm just like saying that, oh, like let's make sure that the hypothesis, the data that we have like aligns with hypothesis. We could start testing multiple cases. We could,
Hmm.
or I don't know if I could implement, like how easy the fix is to implement. And I would
Yeah,
go, we could do the things into parallel. We could add the new logs, start testing new logs, and also start testing a fix. But the problem is, I don't know if how easy it is to implement and how early we can get
right.
the fix. Like logs are simpler. Like here already, Benjamin already suggested let's add logs here, like or
Okay.
here, and let's add here. So it's like I'm crowdsourcing like ideal because I don't want to, I mean I don't want to try to get figure everything myself and guesses because I'm also biased. I mean FYI, I for this I asked like AI to add those logs, so it's logs are simple.
Right.
Fixed, I don't know. I'm still, maybe I can try to vibe code it, but I don't know.
Yeah. Yeah. Um. Yeah, because it might not be intuitive to add that double check to make sure the leader is actually the leader that it receives a index from. Um. But okay, I think it should be quick for me to just let you know like how many hours you need to run for to have a 95% probability that the test isn't or that the bug isn't there. Um,
I
it should
mean,
be that many hours. And like if you wanted to, like if you thought you had a potential fix and you were like, okay, like tonight I'm gonna
mhm,
run a lot of testing to make sure that my fix actually work, you
mhm,
could probably just like run like 6 12-hour tests that night and most likely,
mhm,
yeah, we don't really put a limit on the tests. So if you wanted to make sure that the bug fix worked,
mhm.
I think we'd be fine with you running 6 12-hour tests
Yeah. I
to
mean,
check.
I don't think you pay for the test. I know how it happened. Like, yeah. So I
Yeah,
don't
so
think you care.
yeah, I'll just get back to you on the probability though, on like how many hours we need to go without seeing the bug to be confident that
Mhm.
it's no longer there.
Yeah.
Okay.
My understanding of the costs is the costs go from AWS like credits from CNCF.
Yeah, I don't really know anything about like you'd have to ask Craig. I think Craig would probably know.
I I think I thought like we talked a little bit how it works because that was like something that CNCF. And FYI, I spent like thousands of dollars on CNCF money because I ran like 5,000 node tests for
Five,
scalability of Kubernetes.
uh, which tests? You said no tests?
The scalability, 5,000 nodes
Oh,
for
5,000
scalability.
ability tests. Oh,
Yeah.
wow.
I don't know how big machines you run, but yeah, we spend a lot, or yeah, and
Yeah,
I'm responsible.
we run on Etsy on an M5 metal AWS instance. So I mean, I don't know. I think they have the rates on their website. It's like 6.5 an hour or something. I don't know to rent if you wanted to rent one of those yourself.
Yeah, I would need to check. I don't know AWS enough. I know.
Yeah.
I just know how to check what kind of things we are using. But yeah,
Mm.
I think 5,000. I expect 5,000 medium or like small nodes are still most costly, more
Yeah,
costly.
probably.
Uh, okay, if there are no any questions, everything is clear. I can get into how first you could I can get you through how I got the results I got, and second I can try to add the logs that we need. I don't think this is. I don't know if we'll fit that, but yeah, we might. So okay, so how I got the following case. I think you, Marcus, sent me this dashboard, like this thing with search logs. So basically, what you do, this is like, or I don't even know how it works, but yeah, from multiple runs you can find the failed validations, and for this particular, here we are running on a fork of etcd with additional logs built from different branch. So we have like I think this build or this one run, and apparently I don't know how to find it other ways than what Marcus sent me for now.
We're
But yeah,
making
we
it
looked
easier
for.
though. In the newest update, it's going to be this whole search UI is going to be easier.
Yeah,
So
everything will get better.
yeah, we're always making improvements.
Yeah, so here is the log from the run. I think I was inspecting, and I double checked it by like looking for the requests. I hope we don't duplicate request ID, but yeah, read index matches like 10. Or I can collapse it. I cannot. Yeah, yeah. I'm only interested in the right side now, so I don't think I can fix it. So yeah, I looked for the linearization, and how I looked at, I clicked debug events, and I needed the visualization. So I think so one thing here, I mean, it's fact that linearization failed mm, doesn't help. Yeah, linearization illegal because you don't know where is the failed linearization. So what we need is this like diagram. So I will not start it. It's 5 minutes, takes like 5 minutes or longer to start. I started debug sessions, and I use it to I think I have here. If you use this, you can run the multiverse debugger or this like simulation to dump the history from log. I mean report um, for the run, like robustness, same like robustness test. So I just ran it and got the report because I didn't know how to get the artifacts for that. Um,
Yeah,
so using
just jumping in here. So for the example that you clicked on the left, that 35.999 second example. Like that's just one instance of us finding the
Mhm.
linearization failure. So what Mark had to do is he needed to get the history.html for that instance of the linearization failure. So he like reheated the bug by like replaying the same inputs by clicking on that debug event thing on the top right. And then he extracted the history.html so he could view the whole linearization
Yeah. Looks
yeah.
like the file I have locally is not the same file. I think I did it on different machine, possibly. So I have I uploaded the here. So if you want to follow us, I always try to upload it. So here is the uploaded. Or no, this is the old one. This is the new one. So here is the uploaded report. So you can take a look yourself, or I can do anything. I cannot do also anything without this. So yeah, here you have history.html. So this is how we dump it by default. So you can see it's a little bit different than visualization that you've seen me on the screenshot, because it includes a lot of failed requests. Yeah, I think I can talk, ask Henry what happens here, but I can guess we added watch that starts from gets, and there is a lot of failed gets. Yeah, it's interesting that there is a lot of failed gets, but yeah, this is like much wider, much longer version of what we've seen. So here is also like the read that is failing, but I didn't want to, you know. Didn't want to wait, so I loaded it into robustness testing, the test case, and I generated I removed. There is no option in this UI, but you can remove those requests in like how the report is generated. So it makes it much easier to read. Maybe we could make it easier for future people, for future. But yeah, currently you can get you need to rerun the report and to linearize the requests. Yeah, maybe I can switch to. Maybe I will need to share my full screen just for some time. Yeah, but let me know if you can, if you don't see anything. Maybe that's easier. But yeah, I don't know if this is the report, so let me delete it and copy a new one. So I can copy it here and just make test robustness report. So this should take the report that we generated on antithesis platform and rerun it. Then we have linearization failure. That's great. And we create a file, and this is the file, like a new file that should be exactly like this, the previous one. So if I open it, it's still like have a lot of records. So to make it more readable, I comment out this line, and this removes the failed request, and I can just open and now we have much, it's clearer, less requests, but still like this connection happens. I also have sometimes to eliminate chances that we have bug in in our optimizations that we do for linearization. I also remove patching of history, because it's it's a little bit guesswork. Sometimes we have issues, so I can remove this as a safety and rerun the linearization and get the thing. So what changes is the failed writes reappear because failed writes cannot be easily, like, we need to do some, I don't know, under the hood look up in etcd and cheat a little bit to be able to remove them from linearization, which makes which makes it much cheaper. But yeah, like, but here those requests were unrelated, as we know, because the important stuff happened here between this request and this request. Next things that I do is I have a failed request. I want to know which member it comes from. So I open here, I search from, doesn't it original start? And give me a second. I was hoping for more. That's weird. Maybe it's not indexed. So this is in the visualization we have now start time and end time of each request. So here call and it's called call and return, and this is pretty nice number because it's usually unique number, because usually, like, if you measure time in nanoseconds, usually not many things happen on same exact nanosecond. So I can find this request. That's currently the only way to do that, but it works for me at this state. And for some reason we cannot find no. Oh, sorry, I didn't copy it correctly. This is, let's say, a return time. Hope it works. Okay, so now the VS Code catch up and index filed and now crashed for some reason. Yay. Not. Let me do this again. Okay, so here is the request that failed in the visualization. So I can find this is a range on pods, makes sense, and return the revision free that matches and happen on member this hash. And this is great because I can go back into my my search and I can start seeing timeline of this member. So now so how I can do that, or first I need to identify which member it is. So I need to look at a log that says this is a local member ID. Local member ID. If you filter that, you will find that this member is only reported by etcd1. So I know which member this write or this read happened and what. Yeah, I found the member that the issue happened on. So what next? I can then filter by this member. So we know this is member etcd1. We have etcd1, and we can go back into what we can go back into identifying this read. So we can to do that we can look for range requests because we know this is a range. How range client request started, or so now we have requests when it started and when it ended. So we can look at requests, and here are a couple of responses. So if we filter completed, we can find the requests. And if I remember, this is the last one. So here is a little bit guesswork. I did a little bit math. I mathed it out. Also, maybe a question to Marcus. How I identified which request it is, to be 100% sure, I did a thing where I looked at what is the first request or this is rank linearization. What is the first request? Or I found a request that looks pretty unique. I found what was its start time and call time and return time in Porcupine, so in nanoseconds measured by from some point done by linear by robustness tests, and then I mapped it back to some time here. I found it, and then I
Mhm.
calculated the difference or recalc how to match one time to the other, so the difference between the times, so different start time, and then I found that this request was around 25 seconds, so it was one of those requests.
Yeah, I think like that should work. Like if you pass by like 1,000 nanoseconds in this like Golang thing, it should be 1,000 nanoseconds in the
Mhm.
antithesis time. Um, so yeah, for that amount of time, like if it's 12 seconds, it's going to be very accurate. So that is a good way to do it.
So maybe a question how to improve that. Is there any way we could anchor the time uh, between the both? So what do I mean by this is basically the place that decides what is the base time linearization could, I know, talk to antithesis and says, I'm starting here, or this is my time. Let me know what is my time. Uh, Maybe
Yeah.
I could
Um,
also do that. I mean, I could do that myself in the robustness tests. Maybe I should do that.
could you
But
like if
yeah,
you print it out like f for that first like request start or something?
mhm.
I don't know.
Yeah, I mean, I can anchor it manually on my side. I can improve on that side, but it would be great if I could, have this time
If
like
there's like a
sum up.
message that was like oh here's like the first request and it's starting and like boom we see it's like at 16292, then it's like very easy to
Yeah,
map everything else to that.
yeah, but you would need to always start the investigation from doing that, and I
Yeah,
would prefer to have vtime accessible.
like
Maybe
to switch the V time to like another time or something.
I don't to I don't know. I need to think about. Or my thought was, could we have vtime in like in this? Like, can
In
we
Golang like in that.
uh,
Yeah. The
access on process
the
side?
thing with this time though, I was trying to like I was looking into like where Go like sources this time from, and I think I don't know, it's like the time in milliseconds since like what is it, like 1970 or something? I don't know. It's like some weird like
That's Unix time. It's not weird time. Someone like
yeah.
it's a standard everywhere.
Yeah, so like maybe there's like a way for us to be like, oh yeah, make the V time like Unix time formatted in nanoseconds, and then you could correlate that to the etcd one.
Yes, that
I
would
think that's
work
actually
too.
really interesting to ask.
Or have both, or be able to switch easily, or I don't know. I mean, I also don't care about 99% of, like, if you look at the timestamp, I don't care about 99%. I just care like basically about this part,
Yeah,
really. So it's not, I don't also want a full Unix time, because things here should happen within minutes and not uh, hours or days.
right.
Yeah,
That
but we
makes
can like discuss it. But yeah, I'm saying like we it would be useful to be able to correlate timelines on of requests between those.
okay.
Um,
Yeah, I'll ask somebody about that and I'll let you know what they say.
yeah. So here I found the request, and I can just look it up here. And the failed request, the request was here. So I had the request ID. So I can use it here. And because this request ID is also doing read index requests, which is a separate thing, I need to copy it too, and I can add alternative. And now I can see both. And then I looked at, oh, what are like 11, like read index 11, or if I like do things like this, I can find I've something like I used something like this to do find the commit. Mm, I yeah, I played with both. Like I could use, oh, I filtered. So you need to then remove. Then you need to go back. Oh, I have timeline from one member, so I need to view. I can view all members, and then you can look at this request and transactions, and then you can find the transaction. Oh, it's not easy. How good? Or client. Yeah. So so knowing where like the previous one, this one has 11. So if I did it better, I would also say alternative to this, and then I could just look at first or last transaction before this client request. Yeah. Oh, so then I know like this request, so I can copy it here to the alternative, and then I have a timeline of those like two requests and the read index loop. So yeah, here is the transaction starting, transaction ending with index 11. Then I have read client request started. It starts the loop and it does things on the loop and the loop. Yeah. So this is how I got the timeline. Any questions to that? Okay. So this is how I debug the thing. We ran out of the time. I will not have time to add the logs, but it should be pretty trivial. Like I said, I basically bytecode plus plus with maybe some logic and some hints. But yeah, it's I plan to just copy the Benjamin comment and ask AI to add the logs or update the logs and maybe suggest other places, because it's not super smart. We just need we need poor man's tracing to know where it happens, and I will review it. I hope I reviewed it before. And if there are no questions, I think we can finish for today. Thanks, everyone. Hope to see you in 2 weeks.
Awesome. Thank you, Mark.
Thank you.
Thank you.